All right, this is our last video for Chapter 10 exam review problems. We're going to look at numbers 19 through 22 on your last page. Number 19 and 20 come from a combination of 10.3 and 10.4 and kind of 10.2. It's like the whole chapter where you're finding an angle in radians and it's one of the special triangles. Okay, so this one they want 2 pi over 3. And this is the kind of question where you're going to look at the unit circle that you've filled out on, the blank page and find the 2 pi over 3. It's right here, 2 pi over 3. It's equal to a 120 angle. So we'll plot that out here, and the reference angle would be pi over 3. If you're, again, looking at the radians, the reference angle is the radian measure that has the same denominator. So this is over 3. And that's equal to 60 degrees. Again, looking pi over 3 is the same as 60 degrees. So they want the 3 basic trig ratios. That's the sine, cosine, and tangent. And now that we figured out the reference angle, pi over 3 or 60 degrees, you can look at the bottom of your page to the fractions that you already wrote out for 60 degrees and copy those. They're going to be the basics of our answer. We'll have one last step, but that's the main part of the answer. So the sine is root 3 over 2, cosine is 1/2, and tangent is root 3. The last thing we do on any of the problems that involve angles on this plane or on the unit circle is figure out positive or negative sign. So using my mnemonic, all students take calculus. I see I'm in the quadrant where sine is positive. That means my other 2 fractions, cosine and tangent, are negative. All right, number 20 wants me to use the unit circle for the 3 basic trig ratios for what they're calling beta. And it's negative, just setting up for my answer right there, negative 7 pi over 2. Okay, so that's a weird one, a weird angle. It's negative, and it's also not one of the numbers on this unit circle for the radians. If you look at that coefficient 7 over 2, that's equal to 3.5, 3.1, 3.5, and that's more than a whole circle. A whole circle is 2 pi. So having a coefficient that's more than 2 means you're going more than a whole way around the circle. So you can subtract 2 from that coefficient, subtract 2 from the 3.5 or the 7 over 2, either way you want to think of it, and we get 1.5, which is the same as 3 over 2. So this angle is like the 3 pi over 2 angle, negative because we had a negative to start with. All right, so negative 3 pi over 2, that means if I look up here, I can get an idea of what my answer is going to be like. I see 3 pi over 2 here, but that's positive. So I'm going to look at how far around the circle you have to go to get to that angle. You go 3/4 of the way around the circle to get to 3 pi over 2. To find negative 3 pi over 2, I'm going to go 3/4 of the way around the circle in the opposite or negative direction. So that's 3/4 of the way around the circle in the negative direction. This is the angle that's equivalent to negative 7 pi over 2. And I've ended up on one of the axes. So if you end up on either the x or the y axis when you found your angle, you are not going to use one of the special triangles to come up with your answers. You have to use the coordinates that you filled in for that point. So I've ended up here. The angle I found is equivalent to pi over 2. And I need to use this set of coordinates and the little guide that we wrote up in the corner, the fact that sine is equal to the y value, cosine is equal to the x value, and tangent is equal to the y over x value. That's why I had you write down those things. You won't be able to solve this problem without those. So I'm going to write that set of coordinates there, 0, 1. And then I'm going to figure out the sine, cosine, and tangent. Again, sine is the y value, which is just 1. Cosine is the x value, which is 0. And tangent is y over x. If If you end up on your tangent with a 0 in the denominator, that is undefined, which means you have no solution for tangent. There is no tangent for that angle. Now this is the only problem where you really don't have to figure out whether your answer should have a positive or negative sign, because the numbers and the coordinates for these 4 points, you should have the negatives and positives already. You notice these two here both have a positive 1 in them with a 0, and then these two down here both have a negative 1. So your answers will end up being positive or negative just by using the fact that sine is the x value, or the y value, cosine is the x value, etc. So those are my answers right there. Last two problems have you practice converting between radians and degrees. This is from section 10.4, one of the very first things on that study guide. If you're going from radians to degrees, the conversion factor is 180 over pi. The pi's in the denominator. Having the pi in the denominator lets you cancel out the pi that would have been in the radian measurement they gave you. And then you can just put these numbers into your calculator. You would do 17 times 180 divided by 12, or 17 divided by 12 times 180. Either way, your calculator will give you the correct answer, which is 255. If you're going 2 degrees, make sure you put a degree symbol on your answer. Then on number 22, we are going from degrees to radians. And we start off with a negative number. That's not going to affect how we set up the problem. It just means our answer will be negative. The conversion factor to go from degrees to radians is pi over 180. Same as the fraction we used before, just flipped. Now, I want your radian answers to have a pi in it. I don't want decimals. You can use your calculator, just don't put the pi into your calculator. What you'll do in your calculator is put 600. I'll go ahead and put the negative sign to set up my answer. Put 600 divided by 180 in your calculator, and then have your calculator give your answer as a fraction. Use the math menu, and it'll give you 10 over 3. Make sure you put the negative sign in the front. 10 pi over 3 negative. All right, and that's all for our Chapter 10 problems. Please like and subscribe.